with me.
Yeah, hello.
Hello,
Everyone.
sir.
Sir.
Good evening,
Yeah.
sir.
Good evening, sir.
Good evening.
So,
Good evening. Great to meet you all.
Same here, sir.
so Mr. Shukla has, decades of experience in building PCBs, and in fact, he has experience working with Prithvi missile systems, Agni missile systems, and various other. So he comes with Indian Air Force background, followed by he has been a part of DRDOs, and there he had, a lot of experience designing large scale systems and real systems to be very true. So he has done a lot of hands-on work while designing innovative products for Defense Research Development Organization, ADRD, Agra, and various other. So I thought of he was here in the office today, and I thought of sir, please join us for this workshop. Students might get a lot of more information.
Yeah, and many of the students are working on working along for the defense side, and like they are making drones and few things for the defense sector. And
Right.
nice to meet you, sir. I'm also from Air Force background. My father was also in Indian Air Force.
Oh, great.
Very
Nice to meet you.
Yes, sir.
Nice to meet you. Thank you.
Same, sir.
Yeah, listening.
Okay, sir,
so
Devanshu sir, we'll start with the workshop.
absolutely
Yes.
Over to you, sir. Thank you.
right.
Thank you.
Okay, a very warm welcome, everyone. I believe our voice is clear to everybody. So,
Yes,
though
sir.
we
Your
have
voice is clear.
a little less number of participants, but anyways, we will, try to deliver the max we can. So, the overall idea about this workshop, PCB designing, smart circuitry, is to quickly have an interaction with the students, those who are working on, their own startups and they have hardware involved. So our idea was to give them a quick glimpse about what all tools they can use in order to create their PCBs for their projects. This is the simple idea. Then once you have a little understanding about how PCBs are created, then you can use advanced techniques in order to create industrial level PCBs for your projects. So I have divided the workshop content into multiple categories where I would like to not to go into a presentation format, just that I want to have a real-time discussion so that after this workshop, the students can get their hands on, and they can start creating the PCBs for their project. So I have a thought of discussing two projects. One would be where we will be designing custom, components for PCBs, and then we will be exporting the PCB files, which are ready to manufacture. Second project, we will be using a little advanced circuit with multiple components. And again, we are going to export the PCB files. We call these files as Gerber files. Okay. Then I would like to show you some components about what different kind of PCBs are available, which we can create. So PCBs can be created at a home as well as they can be created in a large industrial manufacturing setting. Both ways PCBs can be designed. But since we are connected remotely, so we might be using tools like Kikid and in order to create the printed circuit boards. Apart from that, we will be having discussions about the resources which we use in order to let's say, since this will be a beginner level workshop, so beginners resources books I will be sharing, those books which you guys can refer and quickly get started with your journey with PCB designing. So that is what is the idea behind this workshop. Okay. Apart from that, we will be having some discussions with VK Shukla sir also. He will also try to discuss a couple of points related to PCB designing, since he has a lot of experience designing the printed circuit boards, that too at home as well as in the industrial setting. So guys, let's go through it. Let me have a quick share of the resources and all which we would want to use. Also, we can organize it in a hands-on setting. So just give me a minute. So what we will be doing, we can get this workshop organized in a hands-on format where I will share the tool names and all. You can download it along with me, and then we can get started by step, how to use the Kikit tool and how to design industrial level printed circuit boards. Okay. So let me share my screen with all of you. Okay. So let us start the discussions. Let me give you a quick brief of my profile. Already, the team has already shown my information, but just for the sake of completion, let me just give you a quick idea. So I have started my professional journey in 2011, and as of now, I have 12 plus years of experience in designing software and hardware products. So I have my experience working on technologies like artificial intelligence, cybersecurity, cloud solutions, and IoT development. So where we can, design industrial level softwares, integrate those softwares with the hardware, and then make an Internet of Things kind of, ecosystem and the products. So my track record is, all about how to efficiently grow an organization, how to increase the revenue within the organization, how to make products which engages customers. So this is the kind of roles and responsibilities I have in my organization. Apart from that, I have worked with both government and private organizations where my overall, objective has always been to provide, enhanced results and make products which have competitive advantages with respect to their business competitors and all for my clients. Now, currently, I hold a position of director at Hackveda and Hackveda Limited. So I'm a proprietor of Hackveda, which is registered in India, and I hold a director position at Hackveda Limited, which is registered in Canada. So I have successfully developed and managed over 250 strategic partnerships with educational institutions and government agencies. And again, coming back to the growth. So when it comes to growing the organization, I have grown organizations with triple digit, growth. So we have sometimes within when if I talk about, post COVID. So we have grown the organizations in more than 100 with more than 100%. So 121%, 140%. So these are like, the growth statistics which I have while I was growing the organizations where I was heading as a director. Apart from that, I have personally developed multiple projects, which are stock market data analysis, applications, which is known as Day Trade Insight. It is a tool which our customers uses in order to find out stock, to invest. Apart from that, I have created multiple digital marketing, applications like Audience Blend, which is a audience aggregation platform. I have also worked on, AI-driven diagnostics, and the product is known as Diagnostic Expert. So this we have already developed. We also have a current platform for internships. We call it as Intern Tracker. So on Intern Tracker, a lot of students do their internships remotely. So this is also one, product which we have. So these are the kind of projects which we develop in Hackvedam. Apart from that, I have, experience working with Defense Research and Development Organization. So DRDO was a customer where we interacted with them. We have trained them on cybersecurity. Apart from that, we have worked on multiple electronic, projects. Apart from that, we have also developed security and patching framework for Android operating systems for defense mobile devices. So we have been a part of the kind of projects which I have shared on my screen. I think the screen is beeping. Okay, so people are, joining in. Okay, fine. Also, I have worked with Department of Education, Ministry of Education, where we have developed the cybersecurity platform for them for school students from 8th standard to 12th standard, where they were, taught cybersecurity program, and around 7 lakh users have joined that program, and the results were very, very, nice, and it was delivered practically to all those school students from 8th standard to 12th standard. So typically we covered around 1040 schools in Delhi region. And all these schools were, Delhi government schools. Apart from that, we have developed multiple projects. So one project was paratrooper locator system. It was a hardware project which we developed for aerial delivery research and development establishment. This is known as ADRDE Agra. And we have, included multiple features like enhanced radio frequency communication. We have done the encryption and analytics part in those projects. So these are, the kind of projects which we have developed during our journey with Hackveda. So my overall significant achievements with respect to communicating with students is I have trained more than 8 lakh students in my journey since I started from 2011, and more than 17,000 faculty members we have trained during our services at Hackveda. So I have experience speaking at various conferences at IITs, IIMs, and many other organizations. And these are some of my top skills. So artificial intelligence, machine learning, data analysis, reverse engineering, all of these technologies I have been working since a decade, and many use cases have been implemented so far. So now this was a little about my education and my experience which I had. I had a couple of certifications as well. So I am a certified information system security professional from DEFCON. Then I have been a certified security expert from CIS USA, which is Center for Internet Security. I have taken multiple exams for cloud, where I got Hurricane Electric certified, IPv6 Sage. I also have certifications with Rackspace. I have also worked with IBM Developer Works for Android applications. And then I have taken, certain certifications from Skillsoft, where my skill was, prospecting and reaching customers digitally. So these were the certifications I have done. Apart from that, there are certain affiliations with IEEE, then from AAFT institution. So these are the kind of, educational background I have with my experience. So coming back to, our agenda of the day. So what we are planning to do is we are planning to get started with designing the PCBs. Okay. And the first tool which we all will be using, before I get into a formal presentation, I would want you all, those who are on laptops, those who have access to computers with them, you can practically understand how we can create PCBs during this workshop. So this would be the tool which we will be using. So Kicked we will be using, which is a schematic capture and PCB design software. So what you all can do is just go to this website, kickit.org, and you can get started with the download. Why I have selected Kickit is the first part is Kickit is free. And second is it is available for multiple operating systems. So whether you use, Linux machine or Windows machine or a Mac machine, Kickit works on all the three. Apart from that, it is an industry level PCB design software. Third part is it is free of cost. So you don't need to buy the product. So with this workshop, we will be using Kickit. There are multiple other tools available. One such industrial tool is Orchid, which many of the manufacturers and PCB fabricators use. So it is also available in free version for academic students. So you can also try Orchid sometimes, but initially to get started with, you all can, reach out to this website, kickit.org, and get started with the download. Once you guys are ready with the download, you guys can give a heads up on the chat so that we can start with the demonstration one by one. So my idea is download this software. By the time I will discuss a couple of theoretical points with 2 reference books. So I'm going to give you access to 2 reference books. These are one of the fantastic resources to get started with PCB design. And I'm going to walk you through with those books quickly so that, within these 2 days, let's say 30% fast, you will get a whole idea about the overall journey and the processes of, PCB design. And then you can follow those books in order to do your hands-on implementations. And I assure you one thing, once you guys are done with, following both of the books with the hands-on, approach, definitely you will be able to design good PCBs. And whatever schematics are available, you can, first you can draw them on paper, and then you can formalize those using these softwares, Kickit, along with the resources which I will give you today. And then definitely you will be able to export industry ready or manufacturing ready PCBs. Also, we will take a couple of hardware examples. I have got certain PCBs I have brought in for this demonstration. These are the PCBs which we have designed at our office also. So we will have a look that this would be the final outcome which you will export. Okay. So we are going to design these PCBs on Kikit. There are various ways to design these PCBs. This is a zero PCB which I have on my hand. If you can see this on the board, this is a zero PCB which you can practically design at home or connect at home. And this one which you can see on my screen is an industrial export version of the printed circuit boards. So we will design something like this. Designing these PCBs are very easy. Okay. The only thing is you have to be clear with the steps. And my idea with respect to this workshop is I'm going to guide you step by step with one or two projects so that you will get to know how to get started. And second, the resources which you can follow uh, twice or thrice. So once you follow those resources twice and thrice, you will have good skills, and any schematic available, you will be able to export them into good PCBs. So that's what we are going to do. Till now, any questions, anybody? You can raise your questions and I'm up for the answer. And then we can proceed further with the workshop. In the meantime, you collect your question. Let me share the link of Kikit website on chat. For all the students, I have shared the link kikit.org. You can download Kikit from here. People, you can raise your hands, those who have joined this workshop from a computer. If you have access to a laptop or a computer machine, please raise your hands. You will be able to follow the steps, okay, Bhavika has raised her hand. So Bhavika, it would be great if you can go to Kikit website and download. We also have Javeer Singh. Javeer, you can also practically implement the contents of the workshop, which we will discuss today. So you guys can download kikit.org. Those who don't have access to laptops or desktops as of now, you have time. If you have the laptop available along with you, make sure you start the machine and join the workshop from laptop. It would be better for you guys. In the meantime, anybody who's planning to start their machines, other people, those who already are on desktop, or on a laptop, they can raise their questions by now. If anything is not clear, please raise your questions. We can have a talk and then we will proceed further. So coming back to Kikit, Kikit is an industrial tool with which you can design printed circuit boards. In short, we call printed circuit boards as PCBs. Okay. There are a couple of benefits with Kikit. First benefit, it is industrial. Many of the components, majority of the components are available. In case if you don't have a component available, you have access to design a custom component. And this will be our first project in today's discussion. So we will take a sample, component, and we are going to design that component in Kikit. That would be our first project, so that you will get to know how components are designed. Secondly, once you guys are done with project number one, we will be having a project number two where we will take an existing circuit and we are going to create a PCB for that. That would be the second project which we might be taking in. Since the time is short, and my whole idea is that you guys, focus on the steps appropriately and do that implementation. So my idea is to share the books and resources with you as well, so that whatever you have learned in the workshop, that will not end as in once the workshop ends. You will have the relevant resources. From there, you can continue your PCB designing journey and reach out to something substantial, and you will be able to export, these PCBs in an appropriate manner. So just give me a heads up, Bhavika and Javeer, if you guys are ready with Kikit, if you have downloaded it, and other students, just Kiran. Then I have another student, I Street, Kanak Ahuja, and Mohit Chauhan. So if you guys, have not got access to the tool, the link is available on the chat. You can download Kikit. And let me get back to the Kikit screen. So now, so coming back to the Kikit website, we are using this tool, Kikit EDA, a cross-platform and open source electronics design automation suite. Okay. So EDA stands for Electronic Design Automation. Okay. The documentation is available, how to use Kikit. It's a very easy tool, and I'm going to walk you through with the steps. You can download the Kikit from here. Okay. I already have a copy of Mac available on my machine, so I'm going to use that. Then what you can do, there are multiple features. Kikit offers you a schematic capture window, or you can also call it as schematic editor. Okay. So what Kikit schematic editor does, it supports everything from the most basic schematic to a complex hierarchical design with hundreds of sheets. Okay. So you can design an industry level printed circuit board or a schematic for the PCB using Kikit's schematics capture tool. Okay. You can create your own symbols. This is one of the advantages of this software, Kikit, where you can create your own custom symbols. It offers you a tool known as symbol editor. Okay. With symbol editor, you can create new symbols. You can create, you can use those symbols in your projects, and you can design the PCB for your convenience. And then those PCBs can be fabricated and can be components can be populated on it, and your industrial product becomes ready. Apart from that, you can use thousands of components which are available in the Kikit library. Kikit also offers you a library of components and symbols, so you can use any of those components and symbols available with respect to your circuits. Okay. Also, there are two great things. You can verify your design with the SPICE simulator. Okay. So what Kikit offers you, once you have done the design, once you have added all the components required for your project, there are two electronic checkers. One we call as electronic rule checker, and then we have a drills rule checker. Okay. So you can use ERC and DRC in order to ensure that there is no error in the design. We are going to use these tools, and we are going to use how electrical rules check will be, utilized. So we will use this while we will be implementing in this workshop. The second editor we have is a PCB editor. Okay. What Kikit offers you, it offers you a PCB editor also. So once you are done with designing the schematic, you can export the annotations, or we call them as netlist specifically. So once your schematic is ready, you can export the netlist, and then you can open that netlist in a PCB editor. What exactly is a netlist? I'm going to let you know again while we will be doing the practical in the workshop. Okay, so I'm going to tell you what a netlist is. Coming back to the PCB editor, what PCB editor does, Kikit PCB editor, you can consider it as, this is a tool which offers you easy designing of the printed circuit boards. Okay. It is the easiest, one of the easiest tools with which you can design the PCBs using the available netlist. Okay. And the netlist can be created using the schematic editors. Okay. So we are going to use this PCB editor also, PCB layout, you can name it. I generally call it as PCB editor. Within the Kikit tool, it is also named as PCB editor. Okay. Then what do we have is, the third feature which we have is a 3D viewer. So whenever you will be designing your PCBs, you can always have a 3D view of the PCB just to have the real glimpses of what kind of PCB is generated. So we are going to also use this Kikit's 3D viewer. This will allow us easy inspection of our PCB, and in order to ensure that it practically fits for the, for whatever product we are creating in. So a 3D viewer will give you a better, view of what kind of PCB you have exported or will be exported. So it offers you a preview. So we will be using this 3D viewer also during our steps of creating the PCB. Then what we have is you have a built-in ray tracer, which offers customizable lighting. You can create realistic images on your, PCBs where you can, show your artwork. You might have seen certain PCBs where the branding of the PCB or the PCB designer or the manufacturer is available. So which means you can use real-time images. You can use these graphics on your PCBs also in order to brand your, PCBs and in order to brand your product. So this feature is also available. We call it as a ray tracer. You can use any image or a company logo, and you can convert that normal PNG file or a JPG file using a bit.
I guess Devanshu sir is um, network lag is there. That's why. Akhilesh,
हाँ देख रहा हूँ मैं.
Guys, am I audible?
Yes, sir. You're audible now.
Yeah, I'm so sorry. My laptop got powered off. But anyways, I'm connected now. Okay. So let me just share that again with you. So is the voice clear? I believe it is not, disconnecting or anything like that.
No, sir.
Just give,
perfect.
It's clear.
is it going fine?
Yes, sir.
Yes, sir.
Fine.
Okay, great. Also, is my screen visible properly?
Yes, sir.
Great. Okay, so I have already shared the link with everybody, which was the Kicked, website. Also, we did a couple of discussions about the Kicked. We already talked about that Kicked is a electronic design automation suite. It offers you a schematic editor, a PCB editor, and a 3D viewer. Okay. We will be using all these three tools in order to design our PCBs right from scratch. And I was talking about the last point about the ray tracer. With ray tracer, we have this facility to select any image, which is a JPG file or a PNG file, and we can convert that image with a converter, which is a bitmap converter, and we can paste that logo on a real-time PCB, and it can be fabricated and finally it can be exported by the manufacturer so as to, give an appropriate branding of the organization or the, developer who has developed that PCB. We can use that. So these are some of the facilities which Kikit has to offer. You can go to the download button. You can download Kikit from here. So once I click on download here, you can see that it is available for Windows, Mac OS, and Linux, and you can grab it through Docker as well. Since I already have a Mac version, I'm going to use it, and you guys can download for your relevant machine. Okay. Let me open the Kikit for you, and let me show you what all Kikit has to offer. You guys can open it on your Windows machine or on Linux machine or on Mac machine, whatever you have. And I'm opening it on my Linux machine for you. Sorry, Mac machine for you. Now, so once you guys are here, you can see that the Kikit offers you a schematic editor. This was the editor which I was talking about, while I was giving the Kikit's description. Then Kikit offers you a symbol editor with which you can, create custom symbols also. You can edit existing symbols as per your choice. Then we have a PCB editor, which can import netlist and can export a PCB. We have footprints editor. Footprints are also very important. It helps us into creating the routes and traces. Then we have a Gerber view. This is the final view of the PCB. With Gerber viewer, we can view what kind of PCB is designed and we can export it. We can send it to the manufacturer to manufacture the PCB files. Then we have this image converter with which you can convert bitmap images to schematic symbols or PCB footprints. Then you have certain calculator tools in order to do calculations of the measurements about where the components will be populated, what should be the space, on the PCB so that there is no collision of the components while you are placing the components on those PCBs. So all these things are available with the Kikit tool. Okay. So now we will be using Kikit, and let us get started with the first project. So I'll go to File, and I'm going to get started with the first project with which where we will be designing a custom symbol, and we will be doing two things. One, we will add an existing component. Secondly, we will create a component so that you get both the ideas that how you can use existing components and how you can create custom components. And finally, we are going to export a simple PCB out of it. In the second project, we might have a little more components, so we will divide this workshop into two simple projects. Now, let's get to the project. So I'm going to name it as new project. So here you have to give the name of the project. So let's say I'm going to give it as NASCOM 1. I'm going to call this project as NASCOM 1. The second project will be known as NASCOM 2. And I'm going to create it in the downloads directory. So I'm going to share this code with all of you also, so that in case if you have to use it later after the workshop, you guys will be able to use it. I'll share that with Akhilesh and Vishal and the workshop organizers. Then you can seek these files from the organizers. So NASCOM 1 would be the name of the project. So once I click here on NASCOM 1, now you can see that you've got the project NASCOM 1.Kikit Pro. Pro stands for project here. There are two files. One is the PCB file, which will be acting as the PCB editor, which we will be using in the PCB editor. Second file we have is nascom.kikit_sch, which stands for schematic. Okay. The first idea would be to get into the schematic editor, then creation of the symbols, then editing the PCB, arranging the footprints, and finally exporting a Gerber file, which will be ready for the view. And then we will be exporting that Gerber file to other manufacturer, and there we can see how they are going to manufacture the PCB for us. So these will be the steps which we will be following in the workshop. Okay. Now, before we get into the PCB designing, now is the right time to discuss a couple of things about what exactly PCB is and what is the requirement. Okay. Now, so I am offering two books for you. Let me just go here. So I've got these two great books. The first book is Eric Bogartin has written a book, and let me just take you to the first page. Okay. And this will be the side. So the name of the book is this. Bogartin's Practical Guide to Prototype Breadboard and PCB Design. Okay, this is going to be the first resource which we will be using. Bogartin's Practical Guide. Let me just copy the name in the chat for you guys. Also, I will try to share that so you guys can also access it with the chat segment here. So resource one, I'm going to call it as resource one. This resource will help you understand the fundamentals of the PCB, okay, with respect to the hardware approach. So here you will get to know about what exactly is a PCB, what kind of material is used in order to create the PCB, what are the different layers available in the PCB, what are the different categories of PCBs which we can design. So PCBs comes from, we call the minimalist PCB is a zero PCB, which does not have any connections. You can use wires in order to connect the components. Then you can have a 32-layer PCB also, and more than that as well. So we can consider 32-layer PCB as a pretty complex PCB. And mostly, you have seen the motherboards. So these motherboards typically have 32 layers, in their designs. So we are going to take multiple samples and we are going to understand them. Second book, which I will be using here in order to give you a quick approach. This would be, let me just take you to one. This is the book, Kick It Like a Pro. This is one of the finest book which I have read. There are many books available with respect to designing the PCBs, but this one is my favorite, Kick It Like a Pro. It's a beginner-friendly book, I must say. So once you are getting started your journey with PCB designing, so Kick It Like a Pro is a very good book. There are around 7 to 8 versions of this book available, and every version is specific to a Kick It version. So the one which I have shared with you, Kick It Like a Pro, is a good to go with the latest versions of the Kick It. You can use them. So the current download which you will do, you can use this book, Kick It Like a Pro, in order to do the hands-on implementations. Now let me just attach. Do we have an option to attach here in the Teams? Actions and apps, loops.
So I
Okay,
guess we can upload.
if
Click on the plus one, I guess.
the plus one, right?
Yeah.
So once I have
You
clicked
can
on
attach. Come scroll down.
I
Please.
can write attach.
Attachment used to be there, sir.
No,
Wait a second, let me check.
I couldn't find an appropriate option here, but anyways, I'll try to get a link and you guys can download it from there, no problem. I'm just going to, the web. You can download it from here, livegen.is. Livegen.is. Yeah, here is the link. You can go here. One is Eric Bogartin. It's Bogartin. Eric Bogartin has also written a lot of books. Here you can download. This one is dielectric. You can use this one also. Dielectric resonator antenna. This is a book. You can download this. Okay, so here is the link. Here's the link to download the Eric Bogarten's, practical guide to prototype board and PCB design. I'm sharing the link here. This is the first link which you guys can use to download. And the second link is Kick It Like a Pro. I'm sharing that as well. Like trend.is. You can go here, you can type in Kick It. And here is the book, Kick It Like a Pro. Here's a book too. So these are the current resources which we will be using, in order to make an understanding of the PCBs. So I'm going to give you a quick glimpse. And typically we will start with the second chapter. I believe you can see this. You can see my screen. Guys, just give me a quick confirmation that my screen is visible and you can see
Yes,
table
sir.
of contents here. Fine. So this is a good book, to have a quick get started. There are some, fundamental understanding about not the PCB designing, but the overall technology of why and how PCBs are created. So you can go through with some of the topics like cost performance trade-offs, these are a good reads, not related to PCB designing, but an overall understanding about the business. You can get a glimpse of that here. Okay, then you can read about, Murphy's law, which is used in PCB designing. Since we have less time, I'm going to directly take you to chapter number 2, from where the PCB technology begins. So in the workshop, we will have a quick talk about what is the PCB technology. Here, first we are having some theoretical discussions. Then again, we'll get on to the Kickit. The tool which you have downloaded, Kickit Pro, we are going to use it. But before you start using Kickit, I would like to show you what Kickit will be offering. With this book, you will get the fundamental understanding of the PCBs and layers and everything. And once you read this, you will have a better understanding of how to use, Kickit features, and then design your PCBs accordingly. Now, so we'll get into this chapter number 2. Acha, main ek kaam aur kar leta hu. Let me just give you a quick brief of the chapters first. So we will be talking about PCB, printed wiring boards, and printed circuit assembly, PCAs. Then you will understand physical design of a PCB. Then you will understand different type of wires which is used. Then you will have a quick read about the solder mask layer, which provides what do we say? The layer on which you can have your labels and everything related to your PCB. Acha, silk screen offers that. Solder mask will give you, where you can create appropriate traces and all. Though we have a copper trace layer, but we will talk about this layer, the solder mask, the silk screen, and what the fabrication vendor needs, as in the Gerber files which you have to send them. So all of these will be very, very important. Apart from that, signal integrity and connects is also a great chapter in order to read it. Then you will have, electrical properties of, the PCBs and all. You can have these are some good reads. So my overall objective would be to guide you with the chapter 2 here so that you have a basic understanding. From this book, it is a good read, but anyways, with respect to our workshop, chapter number 2 is fine, which you can always refer in order to get the basic understanding of what the PCB is. Now, again, coming back to the PCB, what a PCB is, it is a printed circuit board, okay? And what it offers, this offers mechanical, electrical, and thermal platform, on which you can place your components, and then those components can be interconnected, and finally a product can be created out of it. So what PCB offers, and here I have this example of PCB on my hand. Let me just give you a quick show. So this is an example PCB. Okay, can you see that? This is the sample PCB. So now this looks like a single piece, but eventually it does have many layers in it. The one which I have as of now on my hand is a 2-layer PCB. So on one layer, there are the electrical connections and everything. So how that designing and everything is done, we are going to do that, and I'm going to guide you with the appropriate process. Now, let's get back to the tool here. So components and everything you all have already seen. Now, why do we use PCBs again? So the basic idea to use PCBs is you can build electronic systems using the printed circuit boards. Okay. And what all components you have, you can place all those components on the PCB. You can interconnect all those components and you have a ready to use electronic system, with respect to your use case or the problem which you are solving. Now, have a quick little understanding that in the earlier days, vacuum tubes were interconnected and generally they are used till today. But we are not going to have much detailed discussions on vacuum tubes. Our idea is to design the circuit boards. Okay. So we are going to see how we are going to design that. Now what I have is here you have a quick differences between the PCB, the printed wiring boards, and the printed circuit assembly. So what are the differences? So you can see that a bare circuit board with no components attached is known as a printed circuit board. Okay. So a circuit board where you don't have any component populated on it, we call it as a PCB. So this one is an example of the PCB because no component is attached onto it as of now. Okay. I believe you guys can see that. Let me just remove my, camera's background feature. It would be more better for you guys to see. Okay. I believe this is clear. ये है आपका PCB, ठीक है. We call this as a PCB because एक प्रिंटेड सर्किट बोर्ड है और इसके ऊपर अभी कोई कंपोनेंट पॉपुलेटेड नहीं है. ठीक है. कंपोनेंट क्या चीज होती है? मेरे पास अभी मल्टीपल सेंसर्स हैं. सो लेट्स से आई हैव एन अल्ट्रासोनिक सेंसर. ठीक है. ये अल्ट्रासोनिक सेंसर एक कंपोनेंट है एक तरीके का. लेट्स से जब मैं इस कंपोनेंट को इस पे प्लेस कर दूंगा, इवेंचुअली आई डोंट हैव एन अप्रोप्रिएट प्लेस हियर. ये वैसे किसी दूसरे प्रोडक्ट का पीसीबी है. बट लेट्स से सपोज अगर मैं इसको कहीं कंपोनेंट को प्लेस कर देता हूँ, ठीक है, समवॉट लाइक दैट फॉर एग्जांपल, तो दिस विल बिकम और अगर मैं इसको बैकग्राउंड से वायर्ड कर देता हूँ, आई हैव अ बेटर एग्जांपल फॉर यू टू शो. तो मेरे पास एक ऑल्टरनेट जीरो पीसीबी है. जिस ऑल्टरनेट जीरो पीसीबी के ऊपर मैंने क्या किया, एक माइक्रो कंट्रोलर का बेस, एक एलईडी, आई थिंक आप लोग देख पा रहे होंगे, कुछ बेसिक रेसिस्टर्स हैं. इफ यू कैन सी ओवर हियर, आई हैव अ रेसिस्टर हियर, देन आई हैव अ कैपेसिटर हियर, देन आई हैव सम 1x1 कनेक्टर हियर. तो ये कुछ कंपोनेंट्स है जो मैंने इसके ऊपर जीरो पीसीबी के ऊपर प्लेस कर दिए. तो विदाउट कंपोनेंट, अगर आपके पास कोई सर्किट बोर्ड है, अगर कोई प्रिंटेड सर्किट बोर्ड है, इनफैक्ट हम उसको पीसीबी बोलते हैं विदाउट कंपोनेंट. बट अगर उसके ऊपर हम कंपोनेंट लगा देते हैं, ठीक है, और अगर हम उन कंपोनेंट्स को वायर कर देते हैं, जैसे अगर आप पीछे देखोगे हमने इसको सोल्डर किया हुआ है, ठीक है, और भी कुछ प्रैक्टिकल एग्जांपल्स हैं. ये वाला कुछ थोड़ा बेटर बोर्ड है. इट इज अ सिमिलर काइंड ऑफ बोर्ड विच वी हैव प्रिपेयर्ड, जिसके ऊपर एक माइक्रो कंट्रोलर है, कुछ कंपोनेंट्स कनेक्टेड हैं, हमारे पास एक क्रिस्टल ऑसिलेटर है, मल्टीपल कैपेसिटर्स हैं, फिर रेसिस्टर है हमारे पास, देन मेरे पास कुछ ओपन इनपुट्स हैं, फिर उसके बाद में मेरे पास एक एलईडी बटन है. अगर आप इसको देखोगे, इसको हमने जीरो पीसीबी के ऊपर डालने के बाद हमने इसे वायर्ड कर दिया है. आई बिलीव यू ऑल कैन सी. इसको हम बोलते हैं प्रिंटेड वायरिंग बोर्ड, PWB. ठीक है, प्रिंटेड वायरिंग बोर्ड. तो दो एग्जांपल्स हो गए आपके सामने. एक नॉर्मल पीसीबी हो गई जिसके ऊपर कोई कंपोनेंट पॉपुलेटेड नहीं है. ये पीसीबी हम किकेट से बना के एक्सपोर्ट कर सकते हैं. ठीक है, वी कैन डिजाइन दिस पीसीबी इन द किकेट सॉफ्टवेयर, जो मैंने अभी आपको इलेक्ट्रॉनिक डिजाइन ऑटोमेशन सूट EDA जो मैंने अभी आपके साथ शेयर किया है. उसके बाद में आपके पास सेकंड एग्जांपल है जो एक प्रिंटेड वायरिंग बोर्ड है. ठीक है, ये आप लोग देख सकते हैं. और एक और बेटर बोर्ड है मेरे पास, अभी अगर मैं आप लोगों को दिखाऊं, It is a completely programmable, board created for example. तो यहाँ पे क्या है, मेरे पास ये एक ये जो मेरा बेस है, इनफैक्ट ये Atmega 328P का बेस है. Atmega 328P is a microcontroller. I believe many of you, those who have experience with electronics, उन्हें आइडिया होगा. तो हम क्या करते हैं, एक माइक्रो कंट्रोलर को हमने इसे प्लेस कर दिया. आप इस बोर्ड को एक ऑल्टरनेटिव टू आर्डिनो भी समझ सकते हो. ठीक है, हमने क्या किया, सिर्फ Atmega 328P माइक्रो कंट्रोलर ले लिया, आर्डिनो बोर्ड हमने हटा दिया, वो हमने माइक्रो कंट्रोलर यहाँ पे प्लेस कर दिया. ठीक है, माइक्रो कंट्रोलर का बेस है ये. आई डू हैव द माइक्रो कंट्रोलर ऑल्सो. मैं आपको दिखाता हूँ. लेट मी जस्ट शो इट टू यू. ठीक है, ये है माइक्रो कंट्रोलर. इफ यू कैन सी, ये एक 28 पिन माइक्रो कंट्रोलर है मेरे अभी हाथ में. ये माइक्रो कंट्रोलर है Atmega 328P. ठीक है, ये काफी पॉपुलर माइक्रो कंट्रोलर है जो कि आर्डिनो में यूज होता है. ठीक है, इसके स्कीमेटिक वगैरह भी मैं आप लोगों को दिखा सकता हूँ. मोस्टली जो बच्चे इलेक्ट्रॉनिक के प्रोजेक्ट्स बनाते हैं, आर्डिनो, आई थिंक मेजॉरिटी ऑफ देम हैव ऑलरेडी यूज्ड इट और दे माइट हैव एन आइडिया अबाउट व्हाट आर्डिनो इज. तो आर्डिनो का जो बेसिक बोर्ड आता है, उसमें जो पहला माइक्रो कंट्रोलर अवेलेबल होता है जनरली, वो Atmega 328P माइक्रो कंट्रोलर है. तो आप आर्डिनो बोर्ड हटा करके इस तरीके का एक अप्रोप्रिएट पीसीबी बना सकते हैं, जिसमें आपका माइक्रो कंट्रोलर होगा, आपके डिजायर्ड कंपोनेंट्स होंगे, एंड जो भी आपका प्रोडक्ट या सोल्यूशन है माइक्रो कंट्रोलर को यूज करके जो भी आपने बनाया है, वो आप एक पीसीबी के ऊपर डिजाइन करके यू कैन मेक अ प्रोडक्ट आउट ऑफ इट. ठीक है, थोड़ा सा इस पीसीबी के बारे में बताने के लिए आपको मैं कहूँगा, अगर शुक्ला सर थोड़ा सा आप लोगों को बता सकें तो इट वुड बी अ लिटिल बेटर, एंड देन वी विल गेट इनटू डिजाइनिंग द पीसीबी विद द किट. सर प्लीज. तो सर थोड़ा सा आप लोगों को इन पीसीबीज के बारे में बताएंगे, एंड देन आई विल टेक यू टू द theoretical description of them, followed by the practicals.
Thank you, Devanshu,
Thank
for
you.
sharing the screen. Very good evening, everybody, once again.
हाँ, वो म्यूट पे होंगे बच्चे.
Right.
Guys, आवाज आ रही है आप लोगों को? Just give us a quick confirmation.
Yes, sir. We are getting your voice. Good evening, sir.
Okay, nice. See, I understood that you people are from startup program based, right? You are working for a startup. Now, it is very, I will say, it is very tough to start anything. And a startup is really, it needs a lot of patience, lot of collaboration, lot of like-minded people to work together. And it depends what type of startup we have. Especially technological startups are very complicated, but once you prove it, you become boss. You become socially recognized. So in general, just I am telling, please do not lose the patience. Start working, have patience, collaborate with like-minded people. Try to focus on your project and startup. Startup has something clear-cut idea what you are going to do for your company. For it may be for social cause, it may be for education, it may be for industrial products, commercial products. Now, as Devanshu told, he has shown you that PCBs. He has shown this two-layer PCB. This is two-layer PCB. This is industrial PCB. This you will be making after understanding everything, conceptualizing your design, conceptualizing your circuit, then it will come up like this. To go for this, you need certain other things to start with. Because any circuit, if you want to conceive in your mind, realize for its operation, you need to have first its connections, how to make it. Earlier, in earlier days, people used to wire the connections, wire the transistors. Earlier, somebody told in between that vacuum tubes being used earlier. Now these were transformed to transistors. Then further they transformed to ICs, integrated circuit. FETs, then transistor ICs, things like the journey started in electronics like this. Now, in a startup, suppose somebody is interested to make the project for pollution control, because pollution is a very typical thing nowadays. Every city like Bangalore, Calcutta, that Hyderabad, Delhi, it's a fully environmentally, they are so polluted. Now, just I'm telling the example. Suppose somebody has taken the project to make the system, devices for pollution control. Now, definitely it will have smoke sensors. It will have that different types of sensors they will use to make the final product. Now, to make the final product, you as a startup person, in startup, I think 2, 3 will be very highly technical background. Those will be designing the circuits, right? Now, earlier, they used to make the circuit with the help of normal loose wires. They were connecting the circuits, small circuits, with the help of loose wires. Now, once they transport from here to there, these were broken and project was collapsed in between. Once it goes to, even it goes to that HOD of electronics, he says, ये आपका तार टूटा है, ये लूज वायर डिस्कनेक्ट हो गया, LCD नहीं चल रही, power up नहीं हो रहा. So things like this, it was, people were facing lot of problem. Now, it went transformed to zero PCB. Zero PCB means all their points are dissociated. These are not connected to anyone. But it is so easy to conceptualize your design with by using the components and soldering on this particular PCB. See, you make the circuit on your paper first. Schematic you have made on your circuit, on your paper. Now, how many that microcontroller, then how many passive components you have used, like resistance, capacitance, like this. Those components you will solder on this PCB. It will give better strength, and it is just, you may call it a single layer because there is no layering system. There's only one layer. You place the component and you get the connections done. For this, since it is zero PCB, you need to connect the components, and for that you have to be careful in making 5-volt positive voltage and ground negative, because in any circuit here you need to have connections for ground also. In this commercial PCB, the 2-layer PCB, in this ground level is already defined, and components they will place automatically, ground will be connected because it's already grounded inside with the help of traces, copper traces. Now here,
And this I will tell you guys how that ground and VCC and everything is created on the PCB.
Huh.
I'll let you know about
this
it
will
in a minute.
this will be given by Devanshu Shukla. Now, once you conceptualize the circuit drawn on the paper, now you have put the components like resistance, capacitance, that microcontroller, then headers, female headers, male headers, whatever it is, else that LEDs for showing the power. These things, once you have conceptualized on paper, then you put it on zero PCB, solder it with the loose wires, Now, it becomes easy to just show as a project to any person before going to final investing, because a startup you need a lot of fundings. So initially like a PCB, once you make the PCB, you need to invest in PCB. Then somebody will tell, okay, you change something in this. then changing in hardware, it is very difficult. I'm from missile background. Once missile was developed and that launched from Balasur, ITR Balasur in 2000, Agni Prithvi missile system. That customers, they are from defense itself, that Air Force, Army. Then people used to say, sir, please change this particular point from here to there. And it was just uphill task to change anything in hardware, right? So that's why I'm telling, first conceptualize your circuit on this zero PCB, design it properly, test it, ruggedize it, then you go for commercial PCB. Then you go for 2-layer PCB. Yeah, 4-layer PCB. It depends on your space available for making the product. Because if PCB itself it is taking a lot of space, your product will be very heavy. Because if you see this mobile system, it's a best electronics device is a mobile. Earlier, people used to say the radar is the best solution. But here it is mobile is a best technology electronic device because it is having all the things. So in that, if you see that multi-layer PCB is being used. Similarly, as Devanshu told in earlier this one discussion, that motherboard, these are highly multi-layered, that PCB on this motherboard is made of computers. Now, yeah, I just take another 2 minutes. So now, I told just PCBs, once you conceptualize and design with the help of loose wires, test it properly, and now here you need to have clear understanding that what type of components, their rating, their technical parameters, all these things you have to take care. And for that, you need not to waste much of money. Take zero PCB, start soldering, and soldering, I think technical people, they know if you need to have something, I'll just explain about soldering also in other case, but it is very simple. So please invest less money in startup project and conceptualize, design properly, ruggedize it properly, then go for commercial PCB. Then commercial PCB, that tools and everything, Devanshu will explain you. If I get more time sometimes, I will explain something more to you. Okay? Thank you so much.
Okay, guys. So let's just get back. So where we were here. I believe my screen is visible to everybody. So you got a quick understanding of the differences. One is the printed circuit board, which is the PCB, which does not have any component on it. The second board, once you place the component and when you wire them together, it is a printed wiring board. I have already shown the example to you that once you have wirings connecting your components, this becomes a PWB, printed wiring board. And the third one is a complex board, which generally you would have seen on your computer's motherboard. This is the example. So this is a little more complex board. We call it as PCA, printed circuit assembly. We call it as printed circuit assemblies. We also call them as assembled boards. So these are the three categories. One is the PCB, second one is the PWB, and the third one is the printed component or the printed circuit assemblies. Now, what can you export with KickIt? You can export a PCB with KickIt, and once the PCB is available, then the components population can be done, and finally the electronic product can be built. I'm going to give you a quick description of what is the physical design of a PCB. What a PCB contains, a printed circuit board is composed of alternating layers of conductors made of copper foils and dielectrics. So this is an important statement for you. A printed circuit board is composed of alternating layers of conductors made of copper foil and dielectrics. Okay. This chapter 2 is a good to go for you guys. It would be better that you go through with this chapter number 2 once we are done with this workshop. I'll walk you with the main points. Now coming back to the PCB, the board layers increases usually 2 layers at a time. So once we have a minimalist PCB, the one which you see here in the example on my screen. So this is a 2-layer PCB. Okay. The next PCB, let's say if I go level up in order to create another PCB, I can have a 4-layer PCB followed by a 6-layer, 8-layer, 10-layer, 12-layer PCB. And this goes up to 32 layers, 32 layers. There are chances that you can create above 32 layers also, but having a 32-layer PCB is more than enough. It is a more than enough complex printed circuit board. Generally in the industry, you can have a 2-layer PCB, 4-layer PCB, or a 6-layer PCB. These are more than enough for the general electronic products. Now, coming back to the most common dielectric material which is used in these PCB is known as FR4. We call it as, you can call it as fire retardant also. You can call it as, fire retardant is one good name. We also call it as sometimes as fire retardant is fine. Fire retardant 4. There is another name which is generally used in the industry. It is not getting in my mind as of now. But the most common dielectric material is FR4, which is used in order to create the PCB. Now I'm going to take you to what this PCB contains. So if you can see on the screen, and one example which is on my hand, simply you can see a single 2-layer PCB, which is green in color. This is the PCB board. You can see that it is not that thick, when it comes to the real eyes. You can see that it simply it is a size of not more than 2 mm or so. But within this 2 mm, what all we have between the top layer and the bottom layer of the PCB, we have a resin, we have a signal trace, and we have a glass fiber. Okay, so these are the 3 important components which are available within the PCB. So you can read about the resin, signal trace, and glass fiber through this book also. One important thing which we should definitely read from this book is about the bias. Okay, what are the bias? So once you have a PCB like this, can you see that? So if you can see here, this one is the top layer, the current one in the green color which you see. A similar kind of layer we have at the bottom. We call it as a bottom layer. Within this, we can call it as a 2-layer PCB. On the first layer of the PCB, we have a ground. How to create this? I'm going to tell you. On the first layer, we have a ground. Then we have a mid layer. And then we have a voltage layer. We call it as a 3V3. This is the second layer which we have. Okay. Now you can see that you can see some holes within this PCB. We call it as plated through holes, or you can also, generally it is also known as put through holes. So these holes are responsible in order to connect multiple components within the PCB layers itself. So this is how a typical PCB looks like. And we have 3 kind of wires. One is a blind wire, the one which you can see here in the example. This is a blind wire which connects the top layer with the ground. Okay, so this is the blind wire. Second, we have a buried wire. This is the second one which you can see in the example here. And the third one which connects the top plane, you can see that it connects with the bottom layer. And this we call it as a put through hole or the plated through hole, PTH. So it is accessible on the both sides at the top layer of the PCB as well as at the bottom layer of the PCB. So this is what a PCB 2-layer typically looks like. The second thing which you can also see here on the board here is about the size of these PCB. The overall thickness of the PCB is around 0.063 inches. So within this 0.063 inches, you have around 0.008 inch thickness of pre-preg. Then you have the core of 0.039 inches, and then 0.008 inches of pre-preg again, which is the fire retardant material, fire retardant level 4. Also, you can see the kind of copper available in it. So on the top layer of the circuit, we have around 1 ounce of copper. Then again, in the internal inner layer, we have around 1 ounce of copper. On circuit 2, you have 1 ounce of copper. And finally, you have the bottom layer circuit. So this is the kind of, the quantity of the material as well as the size of the material which is used within a PCB. So it is typically very, very small. But within those small layers, there are multiple layers where you have the ground, where you have the volt, and all these are connected using the wires. I believe this is clear till here. Just give me a quick confirmation if you guys are clear till here. Okay, so you can have this book. I have already shared the download link. Also, there are 2 interesting videos within this book, which I would like to share you before I get started with the design. Now within, KickID, you have to work on multiple layers of the PCBs. And it is very important to know what all layers are there on a PCB, because when you select an appropriate layer in the KickID, and then you will be able to, create the component or write your labels and do your activities accordingly. So these are the typical layers of a PCB. First of all, we have a board outline. Second, we have a drill layer. Third, we have a silk screen layer. Then you have a solder mask layer. Followed by that, you have the copper traces. Okay. Then you have the substrate fiberglass layer. Followed by you have the copper traces again. Then you have the solder mask. And finally, again, the silk screen. Okay. So I'm going to interact with some of these, layers as soon as we proceed further. So these are the typical, information which you guys must have about the PCBs before you get started with designing of the PCBs. So now what you all have got to know as of now, you have understood the differences between a printed circuit board, a printed wire board, and a printed, circuit assembly, PCA. You got to have these understanding. Then you got to see that the overall PCB is of 0.063 inches. Within that 0.063 inches, at every layer of a PCB, around 1 ounce of copper is used. Then there are 3 types of wires which helps you connect between the layers. You have a blind wire which connects top layer with the ground layer. Then you have a buried wire which connects the ground and the layer 1 and the layer 2. And then again you have a put through hole which connects the top plane with the bottom plane of the PCB. So you have this understanding as of now. Now within this PCB, there are different layers which you got to know. So you have a board outline, you have the drill layers, then you have the silk screen, you have the solder mask, you have the copper traces. So these are multiple layers which are available. All of these layers can be operated using the KickID tool. So you can use KickID to work on these appropriate layers, establish the connections, and then export a ready to use industrial PCB file. So this book is a good to go for you guys, in order to understand the theoretical concepts of printed circuit board. There are many chapters within this book, and it is a good read. I think you should read this book. You can read it in 2 to 3 weeks and have a little more understanding about the printed circuit boards. There are 2 more videos here. One video which you can see here is a tour of how a commercial PCB fabrication works, okay, and how printed circuit boards are manufactured. This is a very good example. Let me just, copy link for you and share that with you guys on the chat. So here with this, you can have a quick video of how the PCBs are typically manufactured in the companies with the manufacturer. And second is how the components are populated once the PCBs are, created. So the first stage is to create the PCB via manufacturer. Once the PCB is available, there is a video with how industrial components are populated on the PCB. So here is the second video, which I have shared with you guys. So these 2 videos, will give you a detailed understanding of how printed circuit boards are manufactured and then how components are populated. Now I'm taking you back to the practical part of designing the PCBs. Okay. Now getting back to, let's get back to the practical part. Okay. Now coming back to Kick It Like Pro, this would be the second book, which will help you guys in creation of the project. I would want to go step by step so that you guys can also implement it practically. And now is the time where we will be using schematic editors, symbol editors, PCB editors, footprint editors, cover viewers, and if we need any calculations, we will use the calculator. So what I'll do, I'll take you to Kick It Like a Pro, and I would want to take you to not on the basics of Kick It, you can read that, but I would like to take you to this project. So here is the project one, which we are going to use, and we are going to take this project one, which is create an NRF24 breakout board. So this is the project which we guys are going to start. Okay. Don't worry with what an NRF24 is. It is a normal component. We are going to create it. It would be an example for you guys. Okay. So let's see. Now, how many of you have heard about breadboards? Just give me a quick cheers on, on your emojis and all. Those who know about what a breadboard typically is. Okay. You would have seen that you can use a breadboard. You can place your components on the breadboard and then you can make different connections. But anyways, you cannot use breadboards in a commercial product because in case if a connection gets disconnected, your system might not work. So typically using a breadboard in an industrial product is not appreciated. So what do we have to do is we have to ensure that the connections are appropriate. So what do? We design a PCB, we populate the component, and then we solder these components on the PCBs so that there is no scope of disconnections in an industrial product. So similarly, we are going to create a PCB in this particular project. So what you guys have to do, we are going to follow this resource. Currently, I'm on page number 68 of the project. We are going to start a new project. Okay. You all can follow the steps step by step. You can complete the project. Even if let's say in this 2 days of workshop, if we are not able to complete the project in this 4 hours workshop, you guys can follow the book step by step, right where we end, and you can complete your projects as well. Okay. So what you guys can do, you can quickly start Kick It and you can create a new project. What would be the objective of the project? I would like to show you before we deep down, in the steps. The first one would be you will have an interaction with the, schematic editor. We are going to design a new schematic. Apart from that, you will get to have an understanding about the hot list, the hotkeys which we use in order to operate Kick It professionally. Okay. Then you will have an understanding about, basic features like how to turn the grid on, how to select millimeter, inches, and different type of form factors or measurement factors available on the Kick It tool. Then you have options to show hidden pins and the connection angles and all. So these are some of the features which we will explore. Apart from that, let me take you to the final product. What kind of product will you build? Okay. So you are going to have an interaction with the PCB. Then you will have how to add components on the Kick It. You will add different types of symbols. We are going to implement this. So what we are going to do, we are going to have, a 0,1 cross 0,8 connector. We are going to use a connector. You can see that this is the example connector. If I, increase my screen size, 1, 2, 3, 4, 5, 6, 7, 8. So this is the 8-pin connector, which we are going to use in this demonstration. Apart from that, you can create custom symbols also. So I'm going to create a custom symbol for you. Once you guys are done with creation of the connectors, what next we are going to do? We are going to design, a custom part. This will be a custom symbol and the name of the symbol will be NRF24. We already have NRF24 available in the Kick It, but we are going to have it as an example so that you would know how to create custom symbols. In case if you don't find it on Kick It, with respect to your project. Okay. Now, once you guys are done with designing the symbol, then what are we going to do? We are going to export the netlist and everything. Then you are going to do the wirings. Okay. You're going to make the wirings between these components, the connector and the NRF24 custom, symbol which you have created. Once you guys are done with that, the next thing which you guys will do, you will make all these connections, followed by you are going to have electrical rules check. This is a feature which will ensure that there is no error on the connectivity of the board. Okay, so this is an automated tool which we are going to experience, followed by once the connections are checked and we are good to go, the next thing would be, I'll take you to the PCB part. Then the netlists would be exported. Once your netlist or the custom footprints are ready, we are going to organize these footprints, for these custom symbols and all. Finally, you are going to have a PCB somewhat like this. Let me just take you to the bottom. So you will have a project like this. Let's reach out to this. So there are many steps, while creating a PCB. So you will have a PCB designed somewhat like this. So on that PCB, you will have a custom connector, custom symbol, which represents VCC. Then there are certain other, ground and serial clock and various other, components will be created on that PCB. So with this, you will have a quick idea about how, the PCB would be created with first project, followed by you will establish the connections once you are done exporting the netlist. So we are going to export the netlist and everything. And finally, you have to wire the connections on different layers. So I was talking about certain layers like, copper layers, the silk screen, the solder mask. So these are the layers, the edge cut layer. So with KiCad, you can work on every typical layer of the PCB and you can, create wirings and the components, whatever is required on every specific layer of the PCB. Once this PCB will be done, you will have, two components placed on the PCB. One will be the 8-pin connector. Second would be the NRF24, symbol, which we have created. And finally, once you guys are done with the wiring, so you will also try to establish the wiring between those, points, how those wirings are done. And typically you will have a complete PCB, generated with the steps. So this is what we guys are going to do. Okay. Now, finally, you're going to add the text labels and everything, and you will have a guys, am I audible? Akhilesh and Vishal, is my voice
Yes, sir, you
audible?
are audible. Yes, sir, you are
Okay,
audible.
fine. So let's get going with the KiCad editor now. So here is the project NASCOM1 KiCad Pro, which we are going to, create. So click on schematic editor. This would be the first step. And I'll take you back to the book so that once you guys do start your practice, you can do it step by step. Okay. And this is a very nice book, where you will have the detailed understanding of how the designs and everything is, for a PCB is done. So we are typically here. So we are here in order to create a new project and get started with the schema editor. I'm on page number 70 as of now. On page number 70, and I'll take you to the screen. So once I have clicked on the schema editor, you will have a schema editor open for you here. The first step, whenever we start designing this board, we try to, fulfill this information, which is, the information related to the project and, the product which you are creating. So how you can update this information? The first step is to go to File and go to Page Settings. Okay. Once you click on Page Settings, the first thing is the issue date when this PCB is being created. So you can click on this symbol here and you can select the typical date. So today is 31st July 2024. Let's say this will be my first product. So I'm going to use the major version as 1 and minor version as 0. Okay. So we'll start with the board version 1.0. The title of the product would be, let's say, NASCOM custom board. Okay. Custom PCB. So this would be my first product, which I'll be creating, NASCOM custom PCB. The name of the company is Hackveda, or let's say I can use NASCOM just for your reference. And my name is Devanshu Shukla. So I'm creating this project. So these are some of the information which we have mentioned under the page settings. Once I click OK, now you can see that on that PCB, I've got the information available. Devanshu Shukla from NASCOM. We are creating the schematic editor. The title of the product is NASCOM custom PCB. The size is of A4 and the date on which the PCB is created is 31st July 2024. You can quickly save it. You can use Command S, Control S, or else you can use save in order to save what you have done till now. Once you can see that I have zoomed the editor window. So once you get back to if you want to get back to fit, so you can click on zoom to fit. Also, you can use Control 0 or Command 0 in order to zoom to fit, the screen. Now, this is the first thing which we do where we have already specified the information about the board. So now if I take you here, the first is this blank canvas, which you have seen. Also, in order to read about the hotkeys, I think you have the hotkeys somewhere here. I think file. I don't exactly remember, the hot list, but I think it's somewhere here. I couldn't find it here as of now. Place, symbols, hierarchical. I think on my. Anyways, so you can quickly find the hot list as well. I think it would be here somewhere. File, maybe page setting. You can see here, there would be the shortcut mentioned. But since I'm on Mac, I don't have that. It is generally Command question mark and Control question mark to open the hotkeys. But I think in my machine, it is already, I have changed it. So I don't have the hot list as of here, but I do remember it. So I'll let you know some of the common hot keys I use while preparing the board. And in order to open this hot list, on you can use Control or Command O. It is by default. Also, you can check the shortcut on this, book. You will get to see that. So hotkeys are very, very helpful while creating the boards because it helps you, quickly show the component list and all that. Now, coming back to the next, so we have done this part. The page settings information we have already set. Okay. Now, once we are done with setting this page settings information, we will go to the next step. And the next step would be starting the schematic editor for NRF24 component. Okay. Now, what is an NRF24 component? You can choose a list of components from a component chooser. Now, let me show you how a component chooser comes up. So the shortcut is A in Kicked, and you can use A button. And once you click on A, the component chooser will automatically open. Okay. It contains all the footprint libraries and the symbols and everything. One of the best part is using the symbol editor, you can create any of the components required for your project while you will be exporting the PCBs. Now, guys, once you see here you can choose the symbols, and typically there are around 2,01,095 symbols are already here in Kikit. And in case out of this 2,01,095, if you don't find your symbol, you always have an option to create your custom symbol in Kikit. And hence Kikit is a preferred choice of many EDA designers. Okay. Now, the two components which we want to use in this project is, one is NRF24. So NRF24 is a connector. What exactly it is, let me tell you. So NRF24 breakout component, which is being talked in this book, it is a ultra low power radio frequency transceiver. Okay. So what it does, it is already available, but for example, we can recreate it. So this would be the symbol which we will be creating for examples. Okay. There are different types of connectors available. You can see that there is an ultra power 2.4 gigahertz radio frequency transceiver QF20. NRF24 comes in different forms. You can any of these radio frequency transceivers as part of this project which we are considering as of now. Also, you have the option to create the custom connectors. The second, so I'll quickly get back to the book. So what is the objective is to create a sample NRF24 connector is the objective of this project one. So what do we have to do? We have to create a customized NRF24 connector, a symbol. And once the symbol is ready, we have to use it in our schematic, and then we have to do all the connections and export the PCB. Now, I typically take you here. So what are we going to do? This NRF24 connector is connected with a 8-pin connector. If you can see over here, here is this in this image. Here is a 8-pin connector, which will be used to connect the NRF24. Okay. So we might have, we will be connecting our NRF24 with an 8-pin connector. So we want two components as of now in this demo. One, an NRF24 symbol. Second one would be the 8-pin connector. And we can connect both of that, and we have to export a PCB for that. Now, what are we going to do? The first thing which I'm going to create is I'm going to add a 0108 connector, which will be used to connect the NRF24 radio frequency transceiver. So let us see how we can create that. So first would be to add a connection. So what I'm going to do, I'm going to find out a connector. So I can quickly type in CONN for con. Also, you can see that there are various categories of connectors here. So you can also explore it. So you have different types of symbols for connectors. Then you have devices, you have diodes, you have different drivers. Okay. You have FPGA components. Then you have, interface components like Ethernet, HDMI, USB. So there are different types of symbols available for different electronic components. You can see that you have microcontroller units from Cypress. Okay, then you have microcontroller units from Intel, from Microchip company. So there are various types of component symbols are available over here. We also have component symbols for oscillators, potentiometer, power components. For power components, we have 10 volt, 3.3 volt, 5 volt, which are generally used in the electronics. Okay, so you can quickly have this filter facility where you can filter the type of component and you can use that. So now what I am looking for is a connector. There are different types of connectors available. And if you can see that here is a huge list of connectors available. But since I already have an idea that I have to use an 8-pin connector, so there are two types of connectors. Either you can use a socket or you can use a pin. Okay. So do you want a pin or do you want a socket? So as of now in this demonstration, you can typically see if I show you typically the book, I think here it is. I think I missed where the book is. Let me just quickly open it for you. Yeah, here it is. So here we have a connector. So this is an external connector. Okay. So this is not a socket. These are the pins, 8 pins, which we need to create in this particular project. So I'm going to use 8 pins, and typically let me get back here. So I'm going to use this pin. So here's the symbol con 01 cross 08. So this will be, one column, and all these, connectors will be in one column, and there will be 8 rows. So you have 8 rows and one typical column for every, connector pin. So I'm going to select it. Once I click on it, now you can see that I can typically drag and drop this symbol of, connector 0108 on the PCB board. So let's say I'm going to drop it here. I'm going to click. And once I click, you can see that the 0108 connector is available over here on the screen. I believe you guys can quickly see that. So these are the 8-pin connectors, which typically represents 8 pins on a normal PCB board. And if you want, I can show you certain example. If I stop my screen, you can typically see here. Can you see that? This particular component here. So this is 1 pin. You can quickly call it as 0x cross 01. Okay, this is 1 pin. And these, if you can see over here, these are the headers. Okay, so you can these are the sockets. Sorry, these are the pin, and these are the sockets. Okay, so typically what I have done as of now on my board, you can consider that on a typical board, I have just placed one, this 01 cross 08 pin I have plotted on a board. So here on this physical board, it is 1, but typically on my PCB, I have plotted 8 pins approximately. Okay. Now, if you guys can quickly see that these are the pins which are exported. Also, what do we need to do is we need to have the NRF24 component, which is the overall objective to use in this project. So again, you can click on A, you can open your component chooser. Here you can quickly type NRF24. So here is the quick component, NRF24 breakout, which you can typically use. And you can click on OK. So once you build for NRF, you can quickly place it on the board. So guys, can you see that? So we have got 2 components placed as of now, and NRF24 is a typical, transceiver. Though I don't have a symbol, though I don't have a practical NRF24 available with me, but you can quickly consider it as an ultrasonic sensor, for example. So here is a ultrasonic sensor which is physically available with me. But if I have to create a PCB for this ultrasonic sensor, I have to get the appropriate ultrasonic sensor symbol and I have to place it on the PCB. And then the specific place for this connector will be created on the PCB, and then I can fabricate it, I can export it. And once I have the PCB available with me, I can, use the NRF24 or this ultrasonic sensor on that PCB, and my electronic system would be ready. I believe this is clear till here. Now, let us quickly get back to the connections. So the overall objective here in this typical book, which I'm currently referring to, is I have created the 8-pin connector. The overall objective is earlier this NRF24 was not there, in the component library, and typically people has to create the RF24 symbol. So we can also, create it. But as of now, since we have less time, we only have 10 minutes available. So what I'll do, I'll discuss the important part, and I'll skip creation of a custom symbol. This we can definitely do in the upcoming. It will be organized tomorrow 4 p.m. Today, let me use the existing NRF24, and we can see how we can proceed further with the connections to have a typical view. So I'm currently skipping a couple of points and I'm taking you directly to the wiring mode. So suppose I have an NRF24 component. Also, I have a connector and I have to connect them with the wiring. That would be the next process. Okay. Because we have to create appropriate traces and routes on the PCB. So what I typically do, if I can quickly see here, here I have, the appropriate 1, 2, 3, 4, 5 pins available over here. And on the other hand, I have an RF24 breakout, symbol also available over here. And you can see that the zero ground will be connected with 1. Then typically 1, 2, 3, 4, 5, 6, 7 up to VCC will be directly connected to the pins. Anywhere I can connect them to any pins as of now, as far as the connection is concerned. So I'll do one thing. I'll keep 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. ठीक है मैं काम करता हूँ. Let me just reverse it. So मैं इसको one I'll keep it above because I have to connect one with one, and typically I'll connect two with this two, and then I'm going to connect it. और मैं एक काम करता हूँ इधर ही रख देता हूँ. ठीक है. मैं इसे रिवर्स कर देता हूँ मे बी. ठीक है. Not an issue. Let's say just go here and use. Anyways, ठीक है एक काम करते हैं. Let us just make the connections. अभी मैं 8 connections बना देता हूँ. So typically what we can do is we have to wire these connections. Okay. So for now what I'm going to do, मैं 12 connections बनाना चाहता हूँ. जो मेरे पास 1, 2, 3, 4, 5, 6, 7, 8 आप connectors देख रहे हो. I have to connect each of these points with the appropriate point on the NRF24 component. ठीक है. So at the right hand side you can see that we have this add a wire facility and we can get started with creating the wire. So let's say अभी मैं first connection बनाऊंगा. So the first connection I'm going to make it with this. मैं अभी direct connections establish कर रहा हूँ. ठीक है. So first will be connected with second, 2 will be connected with 6, then 3 will be connected typically with 7.
Sir, I guess आपकी screen share नहीं हो रही.
Then I have 4 will be connected with. Yeah, guys. Anybody saying anything?
So screen sharing.
Screen is not shared. Just okay. Can you see that? Can you see that here?
Yes, sir.
Okay. So I have done. The first is connected with 2. I'm just making direct connections as of now here. Also, since the time is a little less, I can walk over with these connections in the upcoming session, which will be organized tomorrow. Just for the sake of completeness, let's see how much I can connect as of now. So I have made some wired connections. So I have 8 pins, and all these 8 pins are typically connected to my components as of now here. Okay. So guys, can you see that? I have done 2 things. One, I have got an 8-pin connector, which I have typically shown you what a 8-pin connector is. An RF24 represents radio frequency transceiver. So these are the 2 components which are used, and generally these pins are currently connected to the pins of the NRF24. Okay. So for today, I think we can stop till here and we can continue from here in the upcoming workshop, and we can have the questions and answers. For now, anybody who has any questions, please let me know. I have just saved the project. Any questions till now? If you want, I can give you a quick walkover. So we have talked about the PCB, the PWB and the PCA. Then we understood the different layers of PCBs possible. Then we have talked about, the different layers of PCBs which we have. We talked about the KiCad and what KiCad offers. So we have used the first feature of KiCad, which is the schema editing facility. Within the schema editing, we got to know about component chooser. From that component chooser, we know that there are around 2 lakh, symbols available. Plus, we have the facility to create new symbols. We have not created any symbol today, but definitely in the next workshop, which will be organized today, if we have time, we will try to create a new connector or a new, symbol for an RF24. I have used an existing NRF24 breakout connector today, or the symbol today. Then what I have done, when I have plotted both of those symbols or components on my PCB board on the schematic, I have just made some random connections. Okay. Tomorrow I'm going to create a new symbol, and then I'm symbols, and then I can take it forward from there. Okay. So these are some of the things which we have done till today. Also, you have understood about the PCB, that a PCB contains multiple layers. We have a top plane, we have a bottom plane, and then we have, the ground layer, and we have the VCC layer. We also got to understand about the wires, that there are 3 types of wires available. One is a blind wire, which connects the top plane with the ground layer. Then you have a buried wire, and then you have a put through or a plated through hole, PTH wire. That PTH wire connects the top plane with the bottom plane, and that is how it establishes the connections between multiple layers. So now, since you already know that there are multiple layers, like the outline, the drill layer, the solder mask layer, the copper traces layer, we will be using KiCad to work on these appropriate layers, and then finally we will be exporting a PCB, which would be ready to, manufactured by the manufacturer, and then it can be used in our typical electronic product. So guys, we can stop till here with respect to the PCB designing. I would appreciate any questions coming from you. If you got any query as of now, you can ask me, and later we can discuss, the further steps in tomorrow's session. Vishal, Akhilesh, Kanak, and I Street. Any questions you guys have, you can please ask. Any questions, anybody? I can definitely believe that it might not be very, very clear to everybody about what all we have discussed, but certainly I have this thought that I have shared the resources. So if you guys have missed anything about KiCad or about the PCB basics or the PCB technology, you already have the resource which I have shared. I have given the direct links from where you can download. You already have a recording of this session where I have also spoken about the page numbers and the specific points from where we started this discussion. So you can always refer to that. Okay. Also, I'm available for questionnaires. You can ask your questions from me with various mediums. Tomorrow, I'm available for the open house session. For this, you can have your questions. Also, you can organize, the mentoring sessions also, in case if you have any questions related to the PCB technology, I would be available there to answer. And all those projects where this PCB designing has to be done, you can book those sessions and you can have an interaction with me. And with respect to your project, I can give you the guidance, how that PCB design requirements would be there for your project, and you guys can make a fantastic startup and a product for NASCOM as well as for the stakeholders, whoever is involved. So guys, I believe I'm clear. Any questions coming from anybody would be appreciated. If you don't have any questions as of now, you can share it to the organizers and they can post me on mail. My email ID is devanshu@nascomfoundation.org. So you can paste your questions there also, and I can reply on emails. So Akhilesh, we can circulate this video to people, those who have not joined today. Maybe they might be occupied with, any other stuff. Any estimation of what would be the participation numbers tomorrow?
So me and Vishal will try to get more participants.
Right.
But
So more
minimum
won't be
10
a
to
problem for me. I don't care about the numbers as of now, but typically those who have need in their projects, they should be available so that it would be helpful for them. Also, if I need to do any changes, you can give me the feedback,
Definitely.
so that I can do the necessary changes as required. And I can, modify my curriculum or the way of delivery wherever the changes or anything is required. I'm open to that. And if we have to make it more relevant, with respect to the NASCOM objectives, so I am open to that discussion also. You can share that with me. My overall idea would be with respect to my experience with the other candidates, those who have, brought their project discussions with me, people like Team Dhal and all that. So I try to organize the session in that way so that it would be, easy for PCB design. But typically, since the strength was a little less today, but never mind. Whenever they can watch the video and they can come up with the questions, I'm available for that. And in the next workshop or next session, we can have more number of students that we can do. In case if less number of people are joining tomorrow, if you want, to postpone it for a couple of days further,